Hello, today we'll be talking about physical and chemical properties. We'll start out by talking about what the difference is between a chemical and a physical property, and then we're going to dive into the two categories for physical properties, intensive and extensive properties. We'll talk about how these differ and what they're used for, and how we can utilize these two different types of properties. At the very end, we'll do a little bit of an activity where you can try to decide and remember which one is a chemical property and which one's physical. Overall, chemical properties describe the ability for a substance to undergo a chemical change. What this means is that a substance will undergo that chemical change and turn into a new substance. Now, this is important. That substance needs to no longer remain the same substance. There needs to be a chemical change. That can occur through breaking and forming new chemical bonds. These can include things like a certain substance being reactive with acids or water, or even the ability for it to corrode or rust. We'll see quite a few examples of different chemical properties, and we'll even talk later on about what chemical changes are in a different video. Now, physical properties describe characteristics that can be observed without changing the substance. That substance can't change into a new substance when we're talking about physical properties and even physical changes. These can include things like color, density, melting point, boiling point, and many, many more. So for example, if I say that a solution is blue, that is a physical property. I don't have to do anything to see that that solution is blue, except look at it. And that doesn't change that solution or substance at all. It just is something that I'm observing. The first type of physical property that we'll talk about are extensive physical properties. So as I said at the start of this video, there's two categorizations for physical properties: extensive physical properties and intensive physical properties. An extensive physical property is one that changes based on the amount of the material. There are many extensive properties, but two that we will use in high school chemistry are mass and volume. So I have a picture of a balance here, and we can see that right now there's no material on it and it says 0 grams. Now let's look at what happens when I add some more material to this balance. We see that a little material has been added and now the mass says 5 grams. We can do this again. We've added a little bit more material and now the mass is 10 grams. And finally, we can do this one more time. We add a little bit more mass and it says 15 grams. Mass is an extensive physical property because as I add more material, so as the material or amount of material changes, the mass increases. Volume is the same way. If we turn on our tap and we plug up our bathtub, as we add more water to the bathtub, the volume of the water in the bathtub increases. Mass and volume both depend on the amount of material. As we add more material, these both increase, but the reverse is also true. If I were to unplug the bathtub, some of that water would drain. We've taken away some amount of material by letting it go down the drain. The volume then would decrease of the amount of water in the tub. So as we add more material, we increase the mass. As we take away material, we would decrease the mass. This is the same with all different extensive properties. They change based on how much material there is. Now for intensive physical properties, these do not depend on the amount of material. These are set based on the identity of the material. And this is a bit different. These can include things like melting and boiling points, concentration, density, and there are many, many more. This list is very short compared to the amount of intensive physical properties there are, but we don't have time to discuss all of them. So I've included here the 4 that we will see at the first semester of high school chemistry, and these are melting and boiling points, concentration, and density. I have a little picture here of some water boiling. Now, it doesn't matter how much water you have. Water will always boil at the same temperature. Now, generally we say that water boils at 100 degrees Celsius. This does depend on certain things like pressure though. So in the case of water boiling at 100 degrees Celsius, that is at 1 atmosphere of pressure. When we get into our gas laws unit, we'll talk about how boiling point and things like that can change. But for right now, we're just going to say that water boils at 100 degrees Celsius. We're going to make that assumption that it's at 1 atmosphere. It doesn't matter if I have a pot this big or even a very tiny mug of water. Both those amounts of water will boil at 100 degrees Celsius. Melting points are the temperature at which something melts. What will happen is we'll take a little sample of whatever we're interested in, and we can put it in a melting point tube. And then as it melts, we'll actually see this meniscus form because now it's liquid metal. Now this works for a lot of things, not just metals, but I like to use the metal example because in a couple of lessons, we'll talk about alloys. But for melting point is very important in chemistry. In this case, I have two pictures of gold. I have a very, very tiny piece of gold, and I have a huge bar of gold. Now, in this case, these are both samples of pure gold. There's no other metals or elements present. It's just pure gold in both of these samples. Now, this one has a very small mass compared to this one up here. So what does this mean for the melting point? In this case, they are exactly the same. These both will melt at 1064 degrees Celsius. Now this is very important. We can use melting point to confirm with the very small sample if it's a certain element or compound. So I'm going to talk a little bit about what we use these extensive intensive properties for, and I think I just gave a little bit of a hint of one thing we can use it for. We will use both types of physical properties in our study of chemistry. We'll talk a lot about the extensive and intensive properties of various compounds and elements throughout our study of chemistry. Extensive properties can be useful in determining the amount of material in chemical reactions. We'll see things like grams and moles in our study in first semester, and we'll talk about how these are important in chemical reactions and what we can use these to predict. Intensive properties are going to be crucial for other things though. Going back to that gold example, you might have heard me say that we can use small amounts to see if it's a certain element or compound. Now this is important. If a very small piece of gold will melt at the same temperature as a very large piece of pure gold, well, we can use that to identify unknown materials or characterize compounds. Now, we can't just use solely melting point to identify an unknown material, but we can use a combination of different intensive properties to identify what an unknown might be. We can also use it to characterize different compounds. If I have a piece of jewelry and I'm unsure if it's gold or pure gold, or even maybe I have a piece of really small pure gold, well, there's certain tests that can be run on that very small piece that are to check their intensive properties to see if they're the same with other pieces of gold. And it doesn't matter how small the thing that we're testing is. We don't even have to test the entire piece. We just need a little bit. Now on this slide, I have a few different chemical and physical properties. What I would like you to do is I would like you to take a moment and pause this video and try to identify if these are chemical or physical properties. I'll give you a chance to pause, go through these, and when you unpause, I will go through each of these 8 properties and talk about if they're chemical or physical properties and why. Now, if you've had a chance to pause, I'm going to go through these now. If something is orange, that's going to be a physical property. I can observe something is orange without changing that substance at all. This is just a property of, let's say, it's an orange solution. That's just what the solution looks like. However, if I say a compound is flammable, that is a chemical property. A chemical change had to occur to find out this property. And then the same thing reacts with oxygen. This is also a chemical property. In order to find out something reacts with oxygen, we need to do a chemical change. And in that chemical change, Something was reacted with oxygen and it formed a new substance. Some metals can react with oxygen and you form a metal oxide, and that's one example. We have formed some new substance. Our next one is something having 10 grams. Now that's having 10 grams as its mass. We know that this is a physical property. We talked about this in our discussion of the two different categories. In this case, this is an extensive physical property. Now for melting at 400 degrees Celsius, this is an intensive physical property. Melting and boiling point over here are both intensive physical properties. If something melts at 400 degrees Celsius or boils at 100 degrees Celsius, it doesn't matter how much material we have, that's going to be set for that compound or element or whatever we're talking about. We have next reacts with acid. This is very similar to the reacts with oxygen. This is going to be a chemical property. And then finally, we have 100 milliliters. This is a volume. Just like 10 grams, these are both extensive physical properties. If I added to this solution a little bit more solution, maybe it would go up to 150 milliliters. And in that case, as you add more material, the volume increases. That tells us these both are extensive physical properties. They will change if we add more material or if we take away some material. I hope this video helped your learning of chemical and physical properties, and you can let me know if you have any questions.